Good afternoon, everyone. I'm Chi from Meta. And over the past few years, our team at Meta has shaped the AI enhancement across billions of videos. And along the journey, we learned what it takes to make it work at scale. And today, we're going to share the ingredients and something we call the flywheel by putting the enhancement, content, and quality signals together. And quick word about me. I'm a research scientist working on the quality assessment and AI enhancement for media. And here is where we are going. In the beginning, the flywheel. We're going to talk about why we need to scale enhancement together with content quality signals. Second, a real use case, scaling SDR to HDR. And finally, the takeaways. Let's start the flywheel. So AI enhancement is everywhere. And taking three most popular categories. For resolution, we have super resolution, making the video sharper and cleaner. For color, we boost colorfulness, brightness, lifting SDR to HDR. For vivid and natural color. And for motion, we have frame interpolation, smoothing the playback. And we are seeing the whole industry investing here. And we are also applying these to our own ecosystem. It pays off. The content looks better, and engagement is improved. However, there's a catch that makes the success really hard. And what is the catch? So the catch is that the quality can silently go wrong. For example, the over-smooth can wipe out the texture, and existing artifacts get amplified. The color shifts, and text becomes nonsense. Imagine that you are an advertiser selling the fresh green grape. If those turn yellow, you won't be happy. And we are seeing this. These are real examples. We are seeing that in our own ecosystem and also across the industry. And here is the uncomfortable part. Those failures only surface when you ship something, and our engagement metrics cannot reliably detect those. But even a rare slip matters because they can land on the video that is important for you. For example, your family video. So what should we really preserve during the enhancement? So it is the original. That includes the color, detail, motion, and text. Each failure previously break exact one dimension of it. So here's the new bar. The enhancement is only good if we can stay true to the original for every dimension and for every video. And because you cannot protect what you cannot see, we need to build the measurement first. And the measurement matters at the scale. At Meta, there are billions of videos being created every day. And even 1 in 1,000 video that is better enhanced, that is millions of bad videos. So which brings to the point that you can only ship what you can measure. And we need to scale the measurement together with the enhancement. And we have two sets of signals. First, the quality signals about how good the content looks, like the sharpness, the smoothness, the temporal consistency. And we also have the content signals. It measures what is in the frame, like the tags, the face, etc. And how those two signals work as a system. So it is a flywheel. And I will walk through this step by step in a real production use case. It starts from an initial deployment where you have a promising model, works really well offline, and you decide to bring it live to a small scale public test, and then you monitor it, and you feel that the engagement is boosted, and also you know where the quality holds and where the system strings. And the wins justify the next step, the scale. You decide to bring it to more videos for larger benefit, and also confirm the win holds. And then you optimize for quality and for efficiency and get a better model. Then it starts the second turn: deploy, monitor, scale, and optimize. It sounds great, but each turn won't be safe unless you can measure what is happening. So what is at the center that makes each turn safe? So it is the fundamentals at the center. That includes the quality signals, the metrics, and the evaluation, also content signals, and the data set. And each step in the production loop that depends on it. When you deploy it, it is the metrics that told you the model was ready. And when you monitored, the metrics called regression. And when you scale, you believe it because it was measured. And when you optimize, the evaluation proved the quality held. And then it is the fundamental that ensure the safety. And in return, what we collected from the production loop, the new data will feed the next round of fundamental so that you can get a better model. So please keep this picture in mind, and we will keep revising this next. So now it is the real use case, scaling SDR to HDR. The journey started when we first enabled HDR. We know that people love it. We see engagement is boosted because of the natural color. And meanwhile, we also found the majority of our library is still SDR, and SDRs keep coming. So to further boost engagement, an obvious opportunity is to bring HDR to all. But the question is, how can we do this automatically at scale without reshooting? So the answer is the inverse tone mapping. And with AI, we are able to lift SDR to HDR, and it pays off. We are getting more vivid and natural color. However, this is also risky because the artifact can be boosted in the smooth gradient, and also the color can shift. And those subtle failures are really difficult to catch. And that's why we build the flywheel. We measure before we scale. And here is the measurement, the fundamentals. So to measure quality, we break it into several dimensions. For example, the spatial temporal color, and we also introduce the safety guardrails, like the color shift and bending. And then we create a set of content signals covering the popularity or the color information and existing failures. And put them together, we get a representative data set for the target use case, so that the downstream tasks like training and evaluation now stand on the solid ground. So the question is, how can we put those signals work together? They work in 3 stages. For training, content quality signals, they tell the model what to learn and where to focus. And for evaluation, we have objective metrics that score the video automatically so that we can measure quality at scale. And for risk measurement, our guardrails will measure the risk and tell whether that is still within the quality bar. So the quality is enforced end-to-end in the inner flow. And now let's go back to the outer flow and see how the 2 sets of signals can steer the production loop. So here's the first half of the production loop: deploy and monitor. Follow one video, it starts as an SDR source. And the targeting uses content signals to tell whether a video is worth enhancement or not. And for those selected, the model will make it an HDR. And then our gating uses quality assessment to tell whether it clears the bar. And only those passed will be encoded and delivered, so that targeting in the beginning, gating in the end. This content and the quality signals can now steer the production view. And since it is running safe, the next question is, can we make it cheaper so that people can benefit more? Which comes to the scale and optimize, the second half of the loop. So the answer is yes. And because we are able to measure the quality, we can push the efficiency hard. And through the efficient architecture and also distillation, we can make our model 10 times smaller than the baseline. That means with the same compute, we can now serve 10 times the video traffic. And then this loop closes. What we learned at scale about quality and system constraints can feed the next round of fundamentals, and we get a better model. So each turn is cheaper and safer. And the loop also compounds, and it generalizes well in 3 key areas. First, enhancement. So SDR to HDR is only one use case, and we also have super resolution, frame interpolation, and more. And each has its own compute and quality trade-off. Next area is compute. We have server and we have on-device enhancement. And server can further be split into CPU and GPU model versions. Then the use case, we have content like user-generated, professional-generated, ads, messaging in the format of images and videos. The good news is that the loop generalizes well so that we don't rebuild the wheel. We just point it to somewhere new. Finally, the takeaways. The first one, doing enhancement at scale safely and reliably is the real challenge. You can only shape what you can measure, and we need to stay true to the original. Second, Flywheel is how we achieve this, with fundamentals inside and the production loop outside. And the wheel compounds and generalize. So in one sentence, just build a flywheel and scale enhancement and content quality signals together. And that's all. Any questions?